So good afternoon, everyone. Currently, everyone is talking about AI, about Gen AI, and about agents. So I'm coming here to talk to you about AI, about Gen AI, and about agents. The reason for this is that we have it implemented. We implemented agents in our customers. We solved real problems, and these strategies are bringing value to our customers. So let's talk a little bit about what is this agents, where does it come from? So biology was also a very big source of inspiration for artificial intelligence. Many methods are inspired in biology, others in psychology, and many other fields. So in this case, here we have an example of a koala and a hardworking ant, so an ant colony. So the koalas are lazy, they don't have much energy, they are isolated, while the ants, they have specialization, so they work as a team. There are ants that are explorers. They go and explore the environment. Other ants are soldiers, so they protect the colony. And other ants are the workers, the ones that carry the food. So if there is a big change in the environment, who you think will adapt better? Well, I'm going to answer for you. I think it's the ant colony. So this is just an example, but there is another example of an agent-based system that is us, our society. And for sure, your organizations where you work are examples of agent systems. So would you prefer to work in an organization where everyone did everything? Or would you prefer to work in an organization where each one of you has their own set of tasks in which you can specialize and you can learn and become better on those set of tasks? So this is the agent. It's not something new in artificial intelligence. It exists for many years. If you see things such as RoboCup, for example, competitions of football between robots, it's also autonomous agents that work as a team. But of course, in this era of generative AI, we are starting to apply this way of viewing and organizing artificial intelligence. Of course, at BI4ALL, we have our own Gen AI framework. So all organizations have data sources. So they have data in different formats. It can be audio, it can be video, it can be websites, images, texts, databases, whatever. So in our framework, we implement parsers that look into this raw data and parse them into different formats that can be used by our agents. So this means that we can have, in our Lakehouse AI, after this parsing, we can have we can have vector format, so data in vector format. We can have the raw data, also can be useful for some applications. We can have summaries of documents, so that when the user asks to summarize a document, we don't need to be always recalculating it. We just go there and bring back the summary. And we can have many other things related with multimodal models, for example, images that we extract from PDFs, etc. So as you see, we have here, this is the basis of our framework. Then, of course, we build the agents on top of this. The agents is something flexible. It can be one agent, or it can be one team of agents. We have also what we call a master agent. So the master agent is the one that coordinates the work, that calls each specific agent for each specific tasks, and then that gets the output from these agents and knows what to do next. Of course, this framework is generic enough so that it can be used by a user directly. It can be used by an API that calls this framework. It can be used by another software. So it's generic enough so that we can use it in different ways. And of course, the architecture itself, it will vary from problem to problem. one very important thing here, and that's why we call it the human-centric agentic AI, in the line of previous presentations that talk about this interaction between humans and agents. So we have the human in the loop. So in many of these stages, the human checks the work from the agents, or the human gives input for the agents to improve the work, to correct some results, to make some changes. So all of this is captured in this framework. I would like also to talk about briefly one use case that we have in the financial sector. So in this situation, we have a company that needs to evaluate many different credits, usually credits that are not doing very well, so people are not really paying them. So they have to analyze a huge pile of documents, documents of different types. Some documents are court orders, court decisions. Other documents have to do with the banks, how the loan is going. So we have to analyze all these types of documents very quickly, because usually these people need to give a value to this set of credits. So this is quite difficult, quite challenging. It requires lots of manual effort. It's very time-consuming and error-prone. So why not to use intelligent agents to try to help here? So that's what we did. What we do is we have different agents that are specialized. Each agent is specialized in one functional task. So to simplify, we could say that, for example, we have an agent that looks into documents from the court. We have another agent that looks into documents from the bank. And then, of course, instead of an agent can be a team of agents, and each sub-agent is specialized in extracting a certain piece of information. So this is what we are doing here. Of course, this is all coordinated by a master agent, and there is human control in the process. So this is how we approach this problem. Of course, with this strategy, because you can process a large volume of information, large language models don't get tired. So after 8 hours of work, they don't make more errors. They make the same errors, but you can have agents checking the results and making sure that the results are good. So we have that also. So this means that we now take less time to process all these amounts of documents. In addition to that, we can also have improved data accuracy, because we have both agents reviewing the work of agents, and we also have humans reviewing the work of agents. So all of this gives higher confidence in the work. And we have then better decision-making support, because we have a good capacity of extracting relevant information from all those documents. So this makes the process much better and more efficient. I would like to briefly talk about other use cases. One, applications review. This was done for the public sector. So companies need to apply to European funding. And this means that there are technicians that need to look into those applications, read them, and fill some forms. We can do this automatically with agents. We implemented that and reduced significantly the amount of time that it takes to the technicians to do this work. So this is another example of AI agents working in practice and bringing value. Also the CVs. So we have, it's common now with LinkedIn, when you open a position in your company, you have 200 or 300 applications. It's so easy to apply, right? So we need to make sure that we look into all the CVs. And we do that by extracting the most relevant information. So we apply that, and that's also a very interesting application. The final one is about content generation. So an application that writes articles. So this application has agents to create the structure, of the article, has agents to write each section of the article, has agents to review each one of this work, and to propose corrections and improvements. So this is a team of agents collaborating, cooperating in order to achieve a good result. So we also implemented that. So finally, just to wrap up, I would like to say that multi-agent systems automate intelligence draining tasks. The advantage that they are specialized, so they can be specialized in each task, which means that they will be more accurate and make less errors. And finally, but not less important, human-centric AI. AI is not against the human. AI works with the human to help the human achieve better results. And with this process, also people will trust more in AI and the processes that are also based in AI. Thank you very much.